Alright, this is the neat algorithm neuroevolution of augmenting topologies playing Snake. So basically what the program does is it takes X amount of inputs and then produces a Y amount of outputs based on what you need the program for. So usually this works well with games and stuff like that. That's mostly the application for it. And the idea of how it works is that it has a neural network. It looks something like you have this many. So this would be like the inputs, and then they are connected to some type of hidden node, and then there's an output. So it's like two inputs, one output. So in this example, you would have these. This had the value that you input to it, and you have the connection. This is like two, -2 to 2. You multiply that by this value, and then you get the hidden node, this value, and then you use a activation function, which is going to usually be ReLU, tanh, or sigmoid, and then you just keep doing this until you get the output. So that's what the neural networks would look like. Standard neural networks, they have fixed topology. That's like the structure. So how many genes and connection genes you have. But in Neat, what it does is it starts off with no connection, just the inputs and the outputs, and it slowly builds onto it. So the purpose of that is so it gets the smallest possible solution without having to create connection genes that are not needed. So instead of connecting everything to each other, which a neural network will do, this will get theoretically the fastest possible solution. So as you can see, this does pretty well. So the four inputs that it takes is it looks to the left, forward, and to the right of it, and it finds the distance between it and the closest obstacle. And then of course the output would be which direction it should go, left, up, or right. So the main drawback of these inputs is that since there's only four and they only give the directions, it can only see one obstacle in each direction. So this happens a lot where if there was like multiple obstacles, it can get stuck and it doesn't have enough information. So this is how you see how that died. It went forward and it didn't see anything, but once it got to that point, if any direction it would go, it would die. So it just gets sucked, and that's just due to the limited amount of range. So you could possibly add more range to this, but that would be the cost of the inputs. So if you do too many inputs, then it would take exponentially longer to train, and that would cause problems on its own. So yeah, that's it.